Well, hello again, geometry students. Good to kind of see you again from this side of the camera. I hope you're having a good week. I'm sure that I have been having a great time sleeping under the stars and exploring caves and that sort of good stuff. This is the Calleva week day 2 video. Let's see. So it should be Tuesday if you're in periods 4 or 8, and Wednesday if you're in period 5. If it's not, then you're watching the wrong video. So please stop this. Stop it now. And go watch the right video. If it is Tuesday and you're in periods 4 or 8, or Wednesday and you're in period 5, then welcome. Let's chat. What I would like to do today first is review your homework questions and then go over the warm-up exercises that you just did. And then today we're going to talk about something called transversals, which is a particular type of geometric object made up of lines, since we are talking about lines and have been. All right, so first, your homework. I asked you please to do section 3.1, numbers 14 through 19 all, sections 3.2, 3 through 9 all, 14 through 16 all, and 19. And then also those examples from, or rather exercises from the handout, homework 3.1 and 3.2. So let's take a look at the textbook questions first. Please get out your textbooks, turn to page 132, where you will see some diagrams that look like these. Okay, here is 14 through 19. So 14, name parallel line to QR. Here's some possible answers. There's QR. Okay, parallel lines are lines that are contained in the same plane and do not intersect. Okay, like UV is in the same plane. XW, TS. So it's like lines that don't intersect and are going in the same direction. Right? Lines that don't intersect and are not going in the same direction, like VW, are not parallel lines. I think probably UV was, I assume, I mean I'm not there, but I predict that UV or TS are going to be the most popular answers, probably UV more popular than TS. Number 15, name a line perpendicular to QR. Well, the only line we can name is QU, line QU, because that's the only line that has a little right angle thing here. The others, we look perpendicular, but we can't assume that they're perpendicular. Name a skew line to QR. I already named VW, so there you go. Name a plane parallel to plane QRS. Remember, planes we name using 3 letters, right? I would actually prefer if this said plane UVW. But UVW, that's the bottom of this prism, this object. If we think of it like a cardboard box, that's the bottom of the box. QRS is the top of the box, UVW, bottom of the box. How many lines can be drawn to fit, or excuse me, how many lines can be drawn that fit the description for number 18? A line through L parallel to JK. How many lines does JK have parallel that pass through point L? Well, according to the parallel postulate, it's exactly 1. It's actually kind of a silly question. They just are checking that you're applying your postulates. There's only 1 line parallel to any line that passes through a particular point. 19, through L perpendicular. So through point L perpendicular to JK, also 1. There's exactly 1 line perpendicular to a line given a point. All right, so that does it for 3.1. Let's take a look at 3.2. The problems from 3.2. I asked you to do numbers 3 through 9. So let's take a look at those first. There's number 3. Write the postulated theorem that justifies the statement about the diagram angles 1 and 2 are congruent. Oh, well, it's because they're across from each other in this intersection. Those are vertical angles. That's the vertical angles theorem. Unacceptable answer is a statement of the vertical angles theorem. Vertical angles are congruent. It's fine. Number 4, J is perpendicular to K. How can we justify that statement? J is perpendicular to K? Well, 1 and 2 are perpendicular. So this is a linear pair of congruent angles. Therefore, they are right. That was one of the theorems that we went over last class. Theorem 3.1. Oh, it says it right there. Gosh, I looked back at my notes. Number 5, write the postulatory theorem that justifies the statement, then given that G is perpendicular to H. G perpendicular to H. Here 5 and 6 are complementary angles. Complementary angles. So theorem 3.2 was the theorem that said if two adjacent angles are also complementary, then it says their non-adjacent side is perpendicular. So here their non-adjacent side is segment this line G and this line H. Number 6, angle 3 and angle 4 are right angles. So we're looking for this theorem or postulate that justifies that we can say 3 and 4 are right. That would be theorem 3.3, the theorem that says if an intersection of a line has 1 right angles, then all 4 of them are right angles. So 3 and 4 are right angles follows from the fact that this is a right angle and theorem 3.3. Lastly, 7, 8, 9, find the values of, lastly for this page I guess, find the values of x. Here x is congruent, is a vertical angle with a right angle, so it looks like x is 90. Here we have an intersection that has 1 right angle, so all of these are right angles. So since all of them are right angles, x plus 45 is 90, so x is 45. And for number 9, let me turn that light back on. For number 9, again, these two angles are complementary because together they form a right angle. So 70 plus x is 90. That means x is 20. Then I asked you to do 14 through 16. All right, so here's 14, 15, and 16. What can you conclude about the labeled angles? The answers are over here in the margin, but let's see if we can just figure it out. The labeled angles 1 and 2, I can figure out are complementary. How can I figure out they're complementary? Well, this intersection is a right angle, so by theorem 3.3, this intersection is also a right angle because all of them are. And when I say all of them, I mean if there were 2 more down here, they would also be right. So 1 and 2 form a 90-degree angle, so they're complementary. And that's what the textbook says too. Number 15, what can we conclude about the labeled angles? Here we're told that n is perpendicular to m. I can conclude that all 4 of these angles are complementary, or excuse me, all 4 of these angles are congruent and they're all right angles. Again, from theorem 3.3. 16 is h is perpendicular to k. H is perpendicular to k tells me that the measure of angle 1 plus the measure of angle 2 is the same as the measure of angle 3 because this is a 90-degree angle. These together are a 90-degree angle. And so angle 1 is 45, angle 2 is 45, angle 3 is 90. What else did I ask you to do? I asked you to do number 19. Number 19 says fill in the blanks. All right. So what we're given is angle 1 is a right angle, what we're asked to prove is angle 3 is a right angle. Here we go. 1 and 3 are vertical angles. That's the definition of vertical angles. Notice that's not given, right? You might say given by the diagram. That's okay. But you don't want to just say given, because really what you are given explicitly is that angle 1 is right. Okay, so angle 1 is congruent to angle 3. That's the vertical angles theorem. The vertical angles theorem says that vertical angles are congruent. Angle 1 are vertical angles, so they're congruent. Then measure of angle 1 is equal to measure of angle 3. Why is that? Well, it's because they're congruent. So we should write that congruent angles have equal measures. Number 4, angle 1 is a right angle. Why is that? It's given. That's given right here. There you go. Number 6, measure of angle of 3 is 90 degrees. The measure of angle 3 is 90 degrees. I skipped one, sorry. 5, the measure of angle 1 is 90 degrees. That's the definition of a right angle. Number 6, substitution property of equality. What should we substitute? Well, we want to get measure of angle 3 is right, so let's substitute this value of 90 in for the measure of angle 3. How do we know that we can do that? What are we substituting? Well, we're substituting that the measures are equal. So we replaced, in this equation, we replaced the measure of angle 1 with a 90. So that's where we get this equation. And then definition of a right angle is that it has 90 degrees. So since it has 90 degrees, it is a right angle by the definition of a right angle. All right, and then there's the handout that I gave you. So that was all your textbook problems. Let's take a look at the handout. Okay, I could probably get this thing back to where it was before. All right, here it is. First, find the slope of line RS according to the given conditions. RS is parallel to AB, and AB has a slope of -3/2. So since they're parallel, they have the same slope, so the slope of RS is also -3/2. Secondly, it's perpendicular to AB, and AB has that equation. Well, we know that perpendicular slopes have opposite reciprocal, perpendicular lines have opposite reciprocal slopes, so the opposite reciprocal of -1/3 is +3/1. I don't know why I always say lastly. Thirdly, parallel to AB, line AB. So RS is parallel to line AB, and line AB is 72 degrees from horizontal. Ooh, interesting. So if line AB is 72 degrees from horizontal, then the slope is 3.078, and since RS is parallel to AB, the slope is just the same. So we should have 3.078 as the slope for RS. Lastly, there it goes again, perpendicular to AB, and AB is 138. So what I did, I just wrote it like this. Let me explain why. So if the slope of AB, I'm going to write it like that, slope of line AB was unknown, right? We did know that it was 138 from horizontal, and that was AB that's being described. So AB is 138 from horizontal. Then I know that the slope for line AB is the tangent of 138, right? It's tan of 138. Now, since RS is perpendicular, I know the slope for RS, which I can write like that, is -1 over the slope of AB. So what I did when I did the problem, I just skipped over all that, and I knew that the answer that I was looking for was -1 over the tangent of 138. And that came out to be approximately -1.11. I asked for 3 decimal places. Shame on me. Oh, it's a 0 there. No, it's a 0.6 though, so. -1.111. Interesting. Okay. All right, next, find the equation of the line that has the properties given. Use your graphing calculator to visually confirm that your solution is correct. First, we want the line that passes through 0, 0 and is parallel with this one. Well, if they're parallel, they have the same slope. So I know that my m value is -5/3. And since it passes through the point 0, 0, the y-intercept is 0. So the equation is just the same slope, x plus 0. So that's it. Next, passes through 2, 1 and is perpendicular to a line that is 54 degrees from horizontal. Interesting. So I did the same thing as I did up here, I did here. It's the opposite reciprocal of the slope of a line 54 degrees horizontal. So that's where that tangent 54 comes in. But it's the opposite reciprocal, so it's -1 over tangent 54. That gives us -0.727. And then if we plug in y equals mx plus b, with m equals that value, x and y equals 2 and 1, and just solve for b, we get 2.453. And then let's look at these proofs. I want to do these proofs for you because. All right, so the first one is if two angles in a linear pair are congruent, then they are both right angles. So here's my horizontal line for my 2-column proof that I've written off of the edge of my paper. There we go. Here's my vertical line. Okay, remember your textbook writes given, prove. We just have a hypothesis and a conclusion. And we take for granted that the thing we're trying to prove is the conclusion, the thing we're given is the hypothesis. So what we're given is two angles in a linear pair are congruent, and we want to get to they are both right angles. So let's start with angle A and angle B are in a linear pair. And let's say that they are congruent. Angle A is congruent to angle B. Why is that? That's given. It's the hypothesis of the statement that we're proving. Secondly, what can I say? Well, I want to get to they're both right angles. So remember, part of planning our proof is really understanding what this means, what we're given. The first thing we know is that because they're a linear pair, they're supplementary, because we've already proven that all linear pairs are supplementary. So I know that the measure of angle A plus the measure of angle B is equal to 180. And the reason that I know that's true is that linear pairs are supplementary. Okay. So I'm seeing here that I've got measure of angle A plus measure of angle B equals 180. I know measure of angle B is going to be the same as measure of angle A. So it looks like if I do some substitution, I could get two measure of angle A's and then divide by 2 and get 90. So I think that's what I'm going to do. My proof is planned, and now I'm going to carry it out, finish carrying out my plan by writing my proof. Okay, so measure of angle A I know is equal to the measure of angle B. That's what this really means, right? So I'm going to say that congruent segments have equal measure. Okay, your book might say something like definition of congruence, but I think this is a better thing to write. And then since the measure of angle A is equal to the measure of angle B, I'm going to use the substitution property of equality to say that the measure of angle A plus the measure of angle A is 180. So that's substitution property of equality. Number 5, That looks like 2 measure of angle A is equal to 180. What did I do there? I combined like terms, so I'm just going to write simplify. And 6, dividing both sides by 2, I get the measure of angle A is equal to 90. So that's division property of equality. I use div here and subs here. Make sure you used subs, not just sub, because subtraction also starts with sub, and so we don't want to be ambiguous. Abbreviation is okay. Ambiguity is not okay. Looks like we need a little more space. Measure of angle A is 90. Number 7, now I know the measure of angle B is 90. How do I know that? Well, up here I know that the measure of angle A is equal to the measure of angle B. So let's call that the transitive property of congruence, or excuse me, of equality. And I'm done. I've got that both of their measures are 90 degrees, so I know they're both right angles. So I'm going to write angle A, angle B, right angles. And how do I know that? I'm going to say right angles have 90-degree measures. All right, so there we go. If 2 angles in a linear pair are congruent, then they're both right angles. Second proof from your homework. If 2 lines are perpendicular, they meet to form 4 right angles. So let's draw a diagram. There we go. If 2 lines are perpendicular, they meet to form 4 right angles. I'm gonna number these angles 1, 2, 3, 4, and I'm gonna rewrite my statement. If 2 lines are perpendicular, then I'm just going to say they form 4 right angles. So let's think about this in the context of definitions, what I'm given and what I need to show, okay, using my 4-step approach to writing proofs. Step 1, understand what you're given. What am I really given here? I'm given that 2 lines are perpendicular. So I know that one of these angles is 90 degrees. I'm going to say, without losing generality, that angle 1 is 90 degrees. Basically, what I mean by without losing generality is that I could say that any one of these is 90 degrees and still have the same proof. I just changed the rest of the numbers to have a similar proof. Okay, so what it really means that my lines are perpendicular is that angle 1 is 90 degrees. So that's what I'm really given. And then what am I trying to show? I'm trying to show that they form 4 right angles, they being the 2 lines. So it looks like what I'm really trying to show is that all 4 of these measures are right angles. Now, this is actually a statement of the theorem, so we cannot use this theorem. We cannot use the theorem that we were given yesterday because I'm asking you to prove it. Otherwise, it'd be a really short proof. Given this stuff, conclusion, it's true. Not very interesting. Okay, so if 2 lines are perpendicular, then they form 4 right angles. Let's get started. So what did I say we were given? We were given that angle 1 is a right angle. So let's say the measure of angle 1 is 90 degrees, and what is the reason? It's that perpendicular lines meet at a right angle. A right angle, let's say. All right. Number 2. Notice that angle 1 and angle 4 are congruent. So I'm going to write actually angle 1, and when I say congruent, I shouldn't have said congruent. I should have said vertical angles. Angle 1, angle 4 are vertical angles. How do we know that? Well, it's given in the diagram. What else do we know? We know that 90 degrees it has measure 1, or has angle 1. We know that vertical angles are congruent. So measure of 1 equals measure of angle 4. So because vertical angles are congruent, so step number 4 looks like measure of angle 4 is also equal to 90 degrees. How do we know that? By substitution property. Or we could even say transitive. I like transitive better. That's the transitive property of equality, folks. All right, so I've got angle 1, I've got angle 4. I still need to do 2 and 3. Notice that once I get 2, I can just use the same argument for 3. So let's do 2. Measure of angle 1 is 90 degrees. Notice that angle 1 and angle 2 are a linear pair. How do we know that? Well, I've got a diagram here. It's given in the diagram. Okay, 6. For angle 6, let's go ahead and just use theorem 3.1. That says, I can't use theorem 3.1 because it says if two angles in a linear pair are congruent, they are right. But I don't know that they're congruent. So I can't use it. Oh well. However, I do know that they're supplementary, so I know that the measure of angle 1 plus the measure of angle 2 is 180 degrees. That's the fact that linear pairs are supplementary. And I know the measure of angle 1 is 90 degrees, so substituting that in, I get 90 plus the measure of angle 2 is 180. Let me get that light again. Okay, then subtracting 90 degrees from both sides. Oops, I can't do that yet. How do I know that? That's substitution property of equality. Number 8. Notice that we're like getting a good list of like reasons we use constantly, like the properties of equality and linear pairs are supplementary. We use these things a lot, and we're going to continue to. Vertical angles are congruent. Okay, we're going to get like, it's like a toolbox, like we're building a toolbox. And the cool thing about geometry is we're using our tools to make more tools. That's the most useful thing you can do with tools, I think. It's like, you know, teach a man to fish. You ever heard that? Of course you. All right. Number 8. You feed him for a lifetime. Okay, so subtracting 90 from both sides, I get measure of angle 2 equals 90. And so how did I do that? I subtracted. So, there's my subbed right after my subs. Okay, we're getting close. We've got 1, we've got 4, now we've got 2. Measure of angle 2 is a right angle, or not measure of angle 2, but angle 2 is right, let's say. How do we know that's true? I know that right angles have 90-degree measures. I should have also said this for angle 4, so let's do that now. Angle 4 is right. How do I know that's true? I know that's true for the same reason. Right angles have 90-degree measures. 11. Let's see if I can do this in 2 more steps. Angle 2 and angle 3 are vertical. I'm just going to put these in one step because I'm running out of room. So angle 2 and angle 3 are vertical. Measure of angle 2 is equal to measure of angle 3. Why is that? That is given in the diagram, and vertical angles are congruent. So I'm just going to write vertical angles. Congruent. Oops. Congruent diagram. And 12. Lastly, if the measure of angle 2 is equal to the measure of angle 3, then the measure of angle 3 is 90 degrees. So angle 3 is right. And why was that? That was a substitution property, or let's say transitive property of equality. And then the last one was that 90-degree measure. Okay, right angles have 90-degree measures. We really should say 90-degree measures imply right angles, because this is the converse, but this is good. Wow, 12, really 13, 14 steps maybe. That's probably the longest proof you've seen so far, although completely intuitive. Getting around to it, little not too tough, but there's a lot to keep track of. We need to really make sure that we're showing that all 4 angles are 90-degree angles, which is what we were trying to show. 4 right angles. Sometimes I like to hold on to stuff like that and just do bam, 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 all 4 like this. I did 2 right there. Maybe just conclude with all 4 are right, and then you could say right angles have 90-degree measures. That would have maybe been better. Keep the suspense up. All right, so there's your homework. I hope that was formative for you. So transversals. Oh wait, the warm-up. Gosh, this is taking a long time. The warm-up should be really quick. Here's your picture. Consider the diagram below. Mark the diagram with appropriate congruent angle marks. That's literally like my favorite thing to do. All right, so this is congruent to this. Instead of using a different number of arcs, I'm going to use different colors. I'll probably do both. 3 is congruent to 6. What else? 4 is congruent to 1. Also, I'm going to color right angles. This blue shaded angle is right. Let's call that purple. Looks like purple. Purple shaded angle is right. This purple shaded angle is right. If shading angles purple is right, then I don't want to be wrong. I think I got that backwards. All right, so measure of angle 31. If the measure of angle 1 is 38, what is the measure of angle 4? Here's angle 1. They're congruent, so the measure of angle 4 is 38. Why? They're congruent angles. What is the measure of angle 2? I don't know. What is the measure of angle 2? Oh, wait, I do know, because the measure of angle 5 is right, and the measure of angle 2 is the same as 5, because they're vertical angles. So the measure of angle 2 is 90 degrees. Why? Because 2 is congruent, angle 2 is congruent to angle 5. That's an equal sign. That's a congruent sign. If the measure of angle 6 is 51, what is the measure of angle 1? Well, what do we know about 6 and 1? We know that this angle is right, this yellow angle. So 6 and 1 are complementary. So if the measure of angle 6 is 51, the measure of angle 1 is 90 minus the measure of angle 6, which is 90 minus 51, which is 39. Cool. If the measure of angle 3 is 42, what's the measure of angle 1? Here's 3 right here. If it's 42, what's the measure of angle 1? Oh, there's no way for me to tell. I give up. Just kidding. What do I know about these 3 angles? I know that these 3 angles form a 180 degree angle, or a straight angle. So I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180. I also know that angle 2 is a right angle because it's a vertical angle with angle 5. So angle 2 is a right angle, so I'm going to just subtract. Am I gonna? No, I'm going to substitute. And I'm going to substitute 42 for the measure of angle 3. So there we go. Now I can solve for the measure of angle 1. 90 plus 42, well, that's 132. So measure of angle 1 plus 132 is 180. And so what's the measure of angle 1? What's 180 minus 132? Let's see if we can do it in our heads. It's going to be 2 shy of 50. So how about 48? Is that right? Seems right. Cool. All right, some of you may have assumed that those were just congruent because they look congruent. So be careful about that. Okay, now let's talk about some newer stuff. Okay. First thing I want to do is describe something called a transversal. Okay, so in order to talk about a transversal, let's talk about the word transverse or transverse. It could be a noun or a verb. If it's a noun, it means basically like the thing that's laying across, let's say. The thing that's laying across. Why is that? Because the verb means to lay or be positioned across. So like for instance, if you do a Google search, for transverse beam, then you'll see lots of structural drawings and photographs of like sorts of structures that have like beams. Maybe this is like the underside of, or maybe like the inside of a tunnel or something. And on the tunnel there's these beams. Well, they're transverse beams because they're positioned across. So then what is a transversal? A transversal is a geometric object made up of two lines being crossed by a third. So a transversal is a geometric object made up of two lines and then a third line that crosses both. So here's an example of a transversal. So here's two lines. These are not parallel lines, so they intersect somewhere over here. We're not interested in that part because that's not where the transversal is. The transversal is right there. Okay, this is a transversal. There's two intersections, one with each line. This here is called the transversing line. It's the line that is doing all of the crossing and the laying across. Okay, this part we call the interior of the transversal, and then the part outside of the lines is the exterior. There's something about transversals that just make me see like train tracks going off into the distance. So here the interior is yellow. And I'll color the exterior green. Okay, now it's important to take these into account mostly for namiology purposes, for naming stuff, notation and vocabulary. So let me draw another transversal. I'm going to try a dry one that's kind of different. Here we go. Here's two lines, and there's their transversing line. Ooh, this is a very interesting transversal, you say. I agree with you, if that's what you say. All right, there are four types of angle pairs that I want to talk about. In order to talk about them very well, I'm going to lightly recolor the interior and exterior of this transversal. And I'm also going to number the angles. Okay. I'm also going to number the angles. You can see the crack under my pad of paper. I've discovered a secret message. You ever do that? The etchings? Okay. Ask your history teacher what an etching is. Not an etching. Is this called an etching? I don't know. Ask your history teacher. Or your art teacher. Okay. So let's go ahead and label these angles 1, 2, 3, and 4. And why not 5, 6, 7, and 8? Okay. We're not so much concerned with what number is which. What we are concerned with is where they're oriented. So I'm going to actually make a dark yellow side here, and then another side that's a little bit deeper green on this side, and on this side. Okay, so here's our transversal, color coordinated for your viewing pleasure. Our first set of angle pairs is our corresponding angles. Corresponding angles are angles that appear in the same orientation in the two different intersections. So with these intersections, we've got like top left, top right, bottom left, top left, top right, bottom left. So corresponding angles are the ones that are in the same place. So like for instance, 4 and 8. 4 and 8 are corresponding angles. Also 3 and 7 are corresponding angles. 2 and 6 are corresponding angles. And 1 and 5 corresponding angles. Next. What comes next? Alternate interior angles comes next. Alternate interior angles. Alternate refers to sides of the transversing line. Here's the transversing line. Interior refers to the interior and exterior that we mentioned before. So alternate interior angles are angles that are in the interior, so we only have 4 possibilities here, and they're alternate, so they're on opposite sides of the transversing line. So alternate interior angle pairs in this case are 2, 7, that's an alternate interior angle pair, and 4, 5. 4, 5 is also an alternate interior angle pair. The next type of angle pair is alternate exterior. Kind of the same thing as alternate interior, except now instead of in the yellow zone, they're in the green zone. They're outside those 2 lines. So looks like 6 and 3 are on alternate sides of the transversing line and are outside the transversing line. And it looks like 1 and 8 are also alternate exterior angles. One more, consecutive interior. consecutive interior angles. Okay, consecutive interior angles are consecutive because they're in a row, and they're interior because they're in the yellow zone, not the green zone. They're between the two lines. So they're ones that are on the same side of the transversing line. So those pairs, in this case, are 4 and 7 and 2 and 5. Okay, we do not number these in a standard fashion. We won't always call this like angle 1. This is angle 1 of a transversal. We don't do that. We just refer to their relationships. Okay, so you can number them however you want. In fact, in the handout that you have, you should see that they've got letters, not numbers. So, but you can't answer those questions yet because you don't know anything about transversals. All right, so I'm going to draw a particular type of transversal to discuss our postulates and theorems. Okay, the first thing I'm going to do is discuss our postulate from section 3.3, which says that if two lines are parallel, then corresponding angles are congruent. Okay, if two lines in a transversal, or I should say of the two lines. So if I have two parallel lines that are being transversed, postulate 15 says that corresponding angles are congruent. So I'm going to mark a couple congruent angles here. Actually, yeah, just two. Just two. All right. So we could, I'm running out of time. I'm not going to do it, but we could make a really good argument based on analytic geometry that this postulate is indeed true. We could demonstrate it using analytic geometry. In fact, we can, because think about it this way. We've already determined using the tangent function that the slope between two lines the angle between two lines only depends on their slopes, right? We've also determined that two lines that are parallel have the same slope. So let's think about it this way. If this is M1 for slope 1, this is M2 for slope 2, this line also has to have the same slope. I knew that was about to happen, because lines that are parallel always have the same slope. So if they have the same slope, then the relationship between the slope of this line and this line is the same as the relationship between the slope of this line and this line. So these two lines, maybe I should mark these angles. It doesn't really matter. They're all corresponding angles are congruent. The angle between the two lines is the same because these two slopes are the same. So this one would be tangent of the greater minus the less. This one would be tangent of the greater minus the less, but you only have you have the same slope you're dealing with here. So you get the same angle either way. So that's how we would demonstrate this using algebra. I'm not going to actually write it out because this video is getting pretty long. Maybe I'll do that. Hey, tell you what, demonstrate it as you do a demonstration, turn it in, I will give you 3 extra credit points. Make it 5 extra credit points. That's a whole warm-up. That's pretty good. Okay, so a couple of things, a couple of theorems. So the postulate 15 says that parallel lines, so that parallel lines in a transversal implies that corresponding angles are congruent. Okay, that's why I've drawn this angle congruent to this angle and the red congruent to the red, because these are two pairs of corresponding angles. Okay, if we didn't know that they were corresponding, so if we only considered the green and the green, then we would have the red and the red because these are two linear pairs. So this angle and this angle are each supplementary to congruent angles, so by the congruent supplements theorem, they're also congruent. But right now we've only applied the postulate that parallel implies corresponding angles congruent. Let's look at the next statement. The next statement is that parallel lines implies alternate interior angles congruent? I'm going to write that as alt-int angles congruent. So parallel lines, my lines are marked parallel here, implies alternate interior angles are congruent. Let's identify the alternate interior angles. So alternate means different sides of the transversing line. Interior means in the interior, between the two lines. So this angle is congruent to this angle. How could we prove that? Well, it's actually pretty easy because these are vertical angles, right? Well, these are vertical angles, so if this is congruent to this, then this is congruent to this by the transitive property of congruence. So I'm going to mark this one green. Next one. The lines are parallel. If the lines are parallel, then alternate exterior angles are congruent. Alternate exterior angles are congruent. So I'm going to write alt-ext angles congruent. Interesting. Alternate exterior angles are congruent. Well, that means that this angle and this angle, those are alternate exterior angles. Also, this angle and this angle are alternate exterior angles. How could we prove that? Well, these angles are corresponding and these angles are vertical. So by the transitive property of congruence, this is congruent to this. So really same argument as the alternate interior angles. Next. Parallel implies what? Oh, I missed one. There it is. Okay, so if our lines in our transversal, if our transversal is a transversal of parallel lines, then consecutive interior angles, that's what I messed up here. Consecutive interior angles, they're not congruent, so be really careful about that. We got a green and a red. Green and red, not the same. Not the same. Consecutive interior angles are not congruent. They're supplementary, right? Green is supplementary to red because these are a linear pair. Okay? So in this case, green plus red is 180. The measure of the red angle plus the measure of the green angle is 180. We can see that everywhere because everywhere we have a linear pair. Actually, we have a green angle and a red angle. So notice that we actually know the measures of all of our angles now, which is interesting because in a transversal of parallel lines, you actually only need to know one of the given angles in order to answer any question you need about all 8 of them, which is why in your concept check, which you probably have in front of you, I've only given you one angle in each transversal, although I drew a double transversal for you, which I thought was pretty sick. The last theorem I want to do for you, this video is getting super duper long. I need to cut it off soon. The last theorem is that if we have a transversal of parallel lines, so here's our transversal of parallel lines, and the transverse angle is, or the transversing line is perpendicular to one line, then it is perpendicular to the other. A better way to say this, I think, is that if a line is perpendicular to one line, then it is perpendicular to all lines parallel. Okay, so that follows actually, how would we prove this theorem? Well, I think it'd be pretty easy, assuming that this is, we already know from our last lesson that if we have one right angle, then all 4 are right. Well, and if all 4 are right and these are parallel, then this is right because let's say this is a corresponding angle with this. So this is right. Well, if this is right, then they're all right. And that's all right with me. So that's how we'd prove that. There's a sketch of the proof. I might assign that proof for you sometime. All right, I want to do one example before I run out of time, and that is, let's do an algebra problem. Let's do some algebra. It'll be really easy algebra. Okay, so here's our transversal. I'm assuming that these lines are parallel, and then a lot of times you'll be given something. You'll be given something about the angles, something algebraic. So let's say 6y is equal to 120. Okay, cool. I can handle that. Let's solve for y. Okay, so step one, the first thing we need to do is analyze the relationship. We need to find the right relationship. Okay, we need to find the right relationship. These are consecutive interior angles, so they're not congruent. I don't want to set them equal to each other. One method students use is they just set things equal to each other, and half the time they get it right. Okay, this would not be one of those times. So instead of just guessing, let's apply what we have learned. The relationship is that these are consecutive interior angles, and in a transversal of parallel lines, consecutive interior angles are supplementary. So what do I know about 6y and 120? I know that 6y plus 120 is equal to 180. So then 6y, I know from the subtraction property of equality, is equal to 60. So y is equal to division property of equality. Let's divide by 6. I get 10. Okay, super cool. So, if you haven't already finished the concept check, the 3-3 concept check worksheet, please do that and turn it into your substitute. I'm going to get that and keep it and grade it and put points into the computer for you when I get back. Your homework for this evening, please do Chapter 3, Section 1, 6 through 9 all, and 21 through 26 all. Okay, please remember to include the diagrams for 21 through 26. You need the diagrams to solve them. Also, please do 3.3, 11 through 26 all. This seems like a lot of problems, but that's mostly just identifying stuff. And then I would also like you to do number 29 from 3.3, but instead of using a 2-column proof like they ask, I want you to try to do it using synthetic geometry. Hey, look, I drew transversal. Didn't even mean to. So please use equations of lines. Use what you know about slope. Parallel slope is the same. See if you can come up with a demonstration that that statement is true. All right. So that's all for today. I hope that you have an awesome night or weekend, depending on whether or not you're going to watch another video. But, you know, take it easy, guys.